Okay, so today we're going to talk about atomic mass. We'll do molar mass actually on Thursday, except we'll just talk about that's what it's called. Last night in your homework, you took the atomic mass, or the average atomic mass that's on the periodic table, which on my big chart is the numbers in red, and you rounded them to a whole number to be able to use it for your homework. Okay, but technically for an isotope, that is not the mass that's on there. What is on the periodic table is an average atomic mass, and it's actually a weighted average. So that's how we calculate the atomic mass. So in actuality, if I look at, say, carbon, if I look at the average atomic mass on the periodic table, it says carbon is 12.01. But in actuality, you could not go out and find an atom with a mass of 12.01 because that's an average atomic mass of all of the isotopes. Okay. A weighted average is also how your grades are calculated. The grades are 60% test, 25% quizzes and labs, and then 15% daily work. So I can't just simply add up all the points in those categories and divide by 3. I have to say 60% of your test points, 25% of your quiz, and 15% of your daily work, and that's how your average is obtained. So it's going to be the same way with our isotopes. Whatever isotope is in a greater abundance is going to have more determining factor in the mass, but we have to take into account the other things. So that's what we're going to learn today. So the average atomic mass is not 1 AMU. We gave it that as atomic mass unit because it's much easier to deal with a proton being 1 AMU rather than that really tiny number, okay, that I gave you. For instance, this like fluorine here is listed. It tells you that the mass of a fluorine atom is actually 3.155 times 10 to the negative 23 grams. That is a hard thing to deal with. So we assign protons and neutrons an atomic mass of 1, and we say the mass of fluorine is actually 19. Easier for us to deal with that number. So what they did is they chose carbon-12 to be basically the standard, and everything else is done relative to carbon-12. That's how they did that. The reason they chose carbon-12, well, one of the reasons is because carbon-12 is in every living thing, and so there's a lot, and so they chose it. It's what it is. Plus, it's got 6 protons, 6 neutrons, 6 electrons. Nice number. Ooh, 6, 6, 6.
Hold up.
I didn't think about that. Never thought about that before. So the relative atomic mass we said is AMU, which stands for atomic mass unit, is what we'll use today. Okay, it is exactly 1/12 the mass of a carbon-12 atom. So carbon-12 has 12 AMUs. One proton and neutron has a mass of about 1 AMU. Remember, the electron is a negligible amount of mass added to the atom. Okay, so let's see how we do this. I'm telling you, it's a very short lesson today. Atomic mass can also be known as some other things, so you're going to need to recognize that. It can be called molecular mass. It could be called ionic mass, formula mass, also molar mass. We are going to use this term more than anything else. That's in white, so you can't see that. I did the chalkboard one while ago, so it was in white. So atomic mass and molar mass end up being the same thing. When we're talking about an atom, we call it atomic mass. Okay, but today we're just going to be calculating the average atomic mass using the isotopes. Okay, tomorrow we're going to do a lab that's calculating the average atomic mass of a sample of candium. Candy, yum. So your isotopes will be Skittles and M&Ms and jelly beans. Those are going to be your isotopes, or 3 isotopes in your sample of candium. Yes, ma'am?
Do we need to do a lab report?
No, it's a labtivity, and what does labtivity mean? Happy dance, I don't have to do a lab write-up. Yeah. It's a labtivity, yeah. So, yeah, I'm giving you candy. That would be mean to give you candy and go, oh, now you got to write it up. No. We used to do it as a LRA and all that stuff. I'm like, this is just a fun little lab. It's basically, it helps you practice that, you know, molar, getting the average atomic mass, but it lets you eat candy, right? Okay. We used to do it with Reese's Pieces, but then there's so many people that have peanut allergies that I felt uncomfortable doing that for 2 reasons. 1, I didn't want anybody to get sick, and 2, I ate Reese's Pieces all day and felt sick by the end of the day. So it's hard to overeat jelly beans. It's really easy to overeat Reese's Pieces. They just taste so good. And we don't do peanut M&Ms either because they're expensive, but that's my favorite candy in the world, so I'm sick by the end of the day if we did that. Okay, so here is the formula that you need for average atomic mass. And what is that funny looking E? Backwards E? Epsilon? What does that mean in math? Summation, right? It means take the sum over summation. Exactly. Make sure you write that. Anytime we're doing atomic mass, molar mass, any kind of that, we're going to always round to 2 decimal places. Okay. On Thursday, I'm going to teach you how to do molar mass, and that it will always be rounded to 2 places. And when I tell you we use molar mass for the rest of the year, I am not lying to you. So Thursday's going to, it's pretty easy, but it's going to be a very important because we use it for the rest of the year. It'll be find the molar mass, and you just do it in your calculator. Okay. So we're going to do an example. Well, I'm letting you still write. I'm just telling you we're going to do an example. I'm just giving you instructions here. Calm down. We're going to do an example, and then I was going to do the first one on the worksheet with you guys, and then I'm going to let you go and work in class. Not go, but like go forth and conquer. And so you have the rest of the class to work on your homework. So hopefully you won't have too much. Most of you might be able to finish it in class. All right, can I move?
Yeah.
All right, here's our example. We have a sample of magnesium that has 3 isotopes. What is the average atomic mass? Okay, so we have 3 isotopes, magnesium 24, magnesium 25, and magnesium 26. So we're going to take that formula and we're going to do the summation of percent abundance times mass. Because we are ultimately dividing by 100, we do not have to take these out of percentages, because we're going to divide by the 100 to get rid of the percentages. Okay, so we're going to take and we're going to say 78.99 times 23.99 plus 10 times 24.99 plus 11.01 times 25.99 divided by 100. So put that in your handy dandy calculators and tell me what you get. Round it to 2 places. Mr. Diamond.
184.31 AMU.
Perfect. So that would be my answer because I rounded to 2 decimal places. Now, this worksheet that you're doing today is going to be kind of like that sig fig worksheet where the answer has to be exact. Because I'm telling you I want it in 2 decimal places, and there's only one way to do that and round it correctly. Okay? So it's going to be kind of like, and you do have to show me the work. Okay? Because that would be too easy for you to just look at your neighbor's paper and go, oh, 24.31, I just did it all on my calculator. So I want you to just write down the process and show me. Okay? Any questions? Anybody dazed and confused as to what I did? Okay? There is another way you could work that. If you wanted to not have to divide by 100 and just go ahead and move the decimal for the percentage, you are welcome to do that. I just found over the years that kids do better by just doing it this way. Because some people don't know how to move the decimal 2 places. I don't know why. But you could just do 0.7899 times 23.99 plus 0.10, and then, but don't divide by 100 if you do that. Okay? If I just confused you by saying that, ignore what I just said and just do it the way I showed you. There is an alternative method if you prefer. Okay? But if I confuse you, rewind and say I didn't say that. Hit that back button like on the remote. She didn't say that. Okay, so let's do the first one on your worksheet. Which is, so it has the element europium. Is got 47.82%. So we're going to say 47.82. That looks like a comma. It's a period. Times its mass of 150.9 plus 52.18% times 152 151.9 divided by 100. So throw that in your handy dandy calculator and tell me what you come up with. We know our units AMU, right? Make sure you put units on there today. Who has an answer? Yes, sir. 151.94 AMU. That is correct. Thank you, Dean. Everybody else get that? Did anybody not get it? So we can clear up any misconceptions. Any last questions? Because this is all we're doing today. It's nice, quick, and easy. All right.